Today I'd like to talk to you about the connection between lines and equations. And to get started, let's look at the equation 2x plus y equals 3. What I'd like to do is start off by finding several solutions to this equation. So how do you find a solution to this equation? There's several approaches. One way is you could pick a number for x and then find out what y should be, or you could also pick a number for y and find out what x should be. Let's get started and say, what happens if x equals 0? So if x is 0, what number does y have to be to give us a solution? Well, to find out, you take 0 and plug it in for x. That gives us 2 times 0 plus y equals 3, or y equals 3. So if x is 0, then y has to be 3 to have a solution to this equation. Let's record this over here in a table. We'll just make a list of what numbers for x and y are solutions to this equation. And as we just saw, when x is 0, y has to be 3. Next, what if x equals 1? What does y have to be in this case? Well, once again, we plug 1 in for x and find out what y has to be. That gives us 2 times 1 plus y equals 3. Or 2 plus y equals 3. And we'll just subtract 2 from both sides. We cancel over here, giving us y equals 1. So when x equals 1, y is also equal to 1. Let's find another one. How about if x equals 2? Once again, we plug it in into the equation and find out what y has to be. So that gives us 2 times 2 plus y equals 3. Or 4 plus y equals 3. We will subtract 4 from both sides. They cancel on the left, giving us y equals -1. So if x is equal to 2, then y has to be equal to -1. And just to mix things up a bit, what if we pick a negative number for x and solve for y? We can do that too. Let's say, what happens if we pick -1 for x? Once again, to find out for y, we plug this in. 2 times -1 plus y is equal to 3. Or -2 plus y equals 3. We will add 2 to both sides because we want them to cancel on the left, giving us y is equal to 5. So if x is equal to -1, then y is equal to 5. Okay, so for the first 4 solutions that we found, what we did is we picked a number for x, put it in, and then we solved to find out what y should be. You can do the other way around if you'd like. That is, you can pick a number for y, plug it in, and solve to find out what x should be. And let's do that now for an example. What if y is -3? I'll admit I picked -3 because I have a feeling it'll work out nicely. So to find out what x should be, we'll plug -3 in for y. So we get 2x plus -3 equals 3. Now 2x plus -3 is the same thing as 2x minus 3. So we have this. And we'll go ahead and solve this. We'll add 3 to both sides, cancel on the left, and we get 2x equals 6. Divide both sides by 2 and you get x equals 3. So if y is equal to -3, then x is equal to +3. So we now have 5 different solutions. The first 4 we found by picking a number for x, and the last one we found by picking a number for y. And to make things simple, we picked whole numbers, but you can pick fractions, any number that you really want. It doesn't really matter. But just to make things easy to understand and work with, I'm sticking with whole numbers. So now what I would like to do is take these 5 solutions and draw them in the plane. And that's because each solution has an x and a y. And so you can think of each solution as a point in the plane because it would have an x coordinate and a y coordinate. To see this, let's move the solutions over. Let's just shrink it a little bit, move it over here, out of the way. And let's bring up some graph paper to give me some nice straight lines to work with. So let's now draw a dot for each of the solutions that we found. The first one was x equals 0, y equals 3. And that is this point right here. The second one was when x equals 1, y equals 1. That is this point right here. Third solution is when x is 2, y is -1. That is this point here. The fourth one is when x is -1, y is 5. That's this point here. And then for the final solution, when x is 3, y is negative 3. So we count over 3, down 3, and that gives us this point here. Now, if you look at these 5 points, you should see a pattern. That is, they all seem to lie on a line. And that turns out to be the case. Let's go ahead and draw a line through these 5 points. If we were to continue making a longer and longer list of solutions to the equation, we would get more and more points on this graph, and they would continue to lie on a line together. And let me draw some arrowheads at the end. And the reason I do this is it's important to convey to people that this line continues forever in both directions. This is one of the big ideas I want you to take away from this lesson. We started with an equation, and each solution to that equation corresponds to a point on the line. And so, because there's an infinite number of points on the line, that means there's an infinite number of solutions to this equation. So one way to think about this line is a picture of all the solutions to that equation. You could spend the rest of your life writing down solutions to the equation, and your job would never be over. There's an infinite number of solutions to this equation, and you can kind of see why. You could pick any number you want for x, and there's an infinite number of numbers. So if you, no matter what you pick for x, if you plug it in, you can solve and find out what y should be. And vice versa. Pick any number for y. It could be pi, it could be the square root of 2, it could be negative 1/2. No matter what you pick for y, if you plug it in and solve, you'll find out what x has to be. And in this case, the solutions to this equation, there's an infinite number of solutions, but if you could somehow draw a point for every single solution, what you would get is that line. And so what we did is we first started with an equation, and we calculated a bunch of solutions to that equation. We drew dots at every single solution, connected the dots essentially, and that gave us a graph. And by drawing the graph, what we did is we drew a picture of the solutions to that equation. That's one of the big reasons you learn how to graph equations, is by graphing an equation, what you're doing is you're drawing a picture of the solutions. And that picture is going to give you a lot of graphical insight. It's going to give you a lot of ideas and understanding for what patterns arise and how you can solve some of these problems. Now, another thing you'll need to learn how to do is, suppose we flip this around. What if I gave you a graph and I asked, what is the equation? How would you go about doing that? For example, what if we had our x and y axes and I drew the graph of a line, and I asked you, find out what's the equation that would give you this line. Another way you could say that is, this line is the solutions, all the solutions to an equation. Can you find out what that equation should be? And that's another type of problem you need to learn how to do in algebra. As we saw, we started with an equation and drew its graph, but you also will need to take a graph and find its corresponding equation. Now, we're not going to do that today, but I want to use this as a way to motivate a lot of the things you're going to learn. So when you do start to learn them, you'll understand there's a reason for that. And that's the big understanding that there's a connection between equations and graphs. That is, you can go back and forth between an equation and a graph and a graph and an equation. So if I were to give you a straight line and asked you to find the equation, well, right now you wouldn't get very far. There's no numbers to work with. It's just there's a picture, but you don't know what the scale is. You don't know where this line crosses the x-axis, and you don't know where this line crosses the y-axis. And in fact, you don't know any point on this line. And without any numbers or explicit points to work with, you're not going to be able to find the equation. But suppose I did give you a few points. Suppose I said, this point is 2, 4. And what if I said this point over here on the left is -3, -1? So I have now given you some concrete numerical clues. I've given you 2 points, I've given you their x coordinates, and I've given you their y coordinates, and I want you to find the equation. How do you do that? The process of going from the graph to the equation is quite different and quite new than going from the equation to the graph. You will, along the way, learn how to do things like find the slope of this line. What is the slope? It's a way to measure how steep the line is. You'll learn about different forms. There's a lot of different ways you can write the equation of this line. Some of them just save you a lot of time. They allow you to very quickly find out what the equation is. Others are a little more difficult to work with, so you're going to learn that there's certain ways you want to write the equation of the line so that you can quickly write down the equation when you're given a few points on the line. And I will say, by the way, you do need at least 2 points on the line to find its equation. If I were to only give you 1 point, it wouldn't work because there's an infinite number of lines that go through that 1 point. But if I give you 2 points, there's only 1 line that goes through those 2 points. And so that's something to keep in mind, is you have to know at least 2 of the points on the line in order to find its equation. But to find its equation, you're going to learn about things like the slope. You're going to learn about different forms. You're going to learn about specific points called intercepts. An intercept is where the line crosses one of the axes. The point where the line crosses the x-axis is called the x-intercept. And the point where the line crosses the y-axis is called the y-intercept. So you're going to learn about those as well, because where the line crosses the axes are 2 points that really help you write down the equation, and you'll see that soon. So that's what I want you to take away from today's lesson, that when you're given an equation, by making a list of its solutions, you can draw its graph, and a graph is a picture of the solutions. Conversely, if I were to give you a graph and give you, in the case of lines, if I were to give you 2 points on the graph, you will learn how to find its equation. Now keep in mind, different equations have different shapes. Some will be circles, some will be parabolas, some will be wiggly, some will be straight. And keep things simple, we're going to start with the simple graphs, and those are lines.